Hi there, and thanks for tuning in. This is our Chapter 3 quiz review on page 128 in your textbook. So let's go ahead and get started going over these answers. For number 1, you're just determining if the relation is a function. This one is a function because each input has exactly one output, and if you graphed it, it would pass the vertical line test. For number 2, this one is not a function because -10 and -8 have two different outputs, and that would not work. For number 3, it says find the domain and range of the function represented by the graph. This is obviously a function because we can draw the vertical line test and it will work. So what we're just basically going to do is list the domains, which remember are the x values, and the ranges, which are the y's. For the x values, I'm just looking at the x-axis, so I have one on 0, 1, 2, 3, and 4. For the y values, I'm just looking at the y-axis, so I have one at -5. I have one at -3, one at -1, one at +1, and then again another one at -3. I don't have to list the -3 twice, so what I can do is just list -5, -3, -1, and 1. Okay. Again, here's some more domain and range questions. Notice with the x values, it is not showing where we would be stopping because it has these arrows. That means it's going to continue. So we would say for the domain in the x, because it could be anything from the east to the west, basically, we're going to say all real numbers. Okay, but for the range, it's a little bit different. Notice we're starting up at 3, and then it gets smaller and smaller and smaller. So for this one, the range just can be y is less than or equal to 3. So it could be anything lower than or equal to 3. For number 5, this one's a little bit more cut and dry. The domain is going to be a range here, or an interval, and same thing for the range. The domain anywhere from -3 to +3. So -3 is less than or equal to x, which is less than or equal to +3. And then the y, or the range, would be anywhere from -1 to +3. So -1 is less than or equal to y, which is less than or equal to 3. Okay? For number 6, it says determine whether the graph, table, or equation represents linear or nonlinear function. This one represents linear because it is a line, and that's the easiest way to determine a graph. If you do have a table, though, you do just want to make sure that the table is increasing steadily. If you look at number 7, we're adding 5 to each side, which is okay over here on the x. But here we have +4 and then +3. So this would be nonlinear because it's not a consistent rate of change. So in order to be linear, it has to be a line or prove a consistent rate of change on the table. For this one, if you distribute the x, you'll get y is equal to 2x minus x squared, and right away, this guy makes it non-linear because this equation cannot be rewritten as y is equal to mx plus b. For number 9, we're just going to look at discrete or continuous and then explain. For this one, you notice the depth is 33 feet and then the pressure is 2. The reason this one would be continuous because you can go to any depth in this example. You don't have to just go to 33 feet. You can maybe go to 34.5 or 98.76, okay? So that would be continuous. However, this one, the hats example for number 10, would be discrete because when you go to the store, you can only buy whole hats. You can't buy 2.5 hats. So that's why that would be discrete. For number 11, find the value of x for when w of x is equal to -3. So I'm just going to plug in -3 where w of x is, and then solve for x. So I'm going to minus 7 from both sides. I get -10 is equal to -2x, and then divide both sides by -2 so that x is equal to 5 for number 11. Number 12, you're just graphing. Remember with these, you're doing graphing with an input-output table. We will eventually learn how to graph differently, but for now we can just do -2, -1, 0, 1, and 2. So if I plug in -2 here, I get +1, -1, I get +2, and then 3, and then 4, and then 5. So notice I did get a constant rate of change, which represents a linear function, and then I'm just going to graph my points. So here are my points, and then all you have to do is just connect your dots. Obviously yours is going to be a little bit straighter than mine, a little bit nicer looking for that. Same thing we're going to do here for 13. We're going to graph the linear function. Again, we will start with writing our table. Oops, it's p of x. So here are my points, -2, 5, and I'm just going to go ahead and graph them. Here are my new points, and it is a descending order. So when I connect my points, it's a descending line. For number 14, I would maybe suggest something right here. Whenever you're finding the values to plot points, sometimes the points that we use may not be the best. So what I did here is I actually just used 3's to plot points, because when I multiply by 3's, it's going to give me a whole number. So I did -3, 0, and +3, and that helped me find a whole number. So if I plugged in -3, I basically can cancel out these and get -2 as my whole number. 0 is just going to be 0, and then when I plug in a +3, that's going to give me a +2. So just keep that in mind. It might help you to use only a number where you could get a whole number here, so that when you plot your points, you're not dealing with decimals or fractions. If you did that, that's fine. You should still have the same or a similar graph to mine. Okay? For number 15, it talks about identifying the independent variable. So I'm going to write my answers down here. The independent variable is going to be the input, and the input would be the number of video games. Because that's the first thing that you decide, and that would be R. Where dependent would be the price, so that would represent M. Okay, so those are the variables M and R. For letter B, the domain and range. For the domain, you could say the domain could be 0, 1, 2, 3, 4, 5, because you get anywhere from 0 all the way up to $5 or 5 video games. And then the range, I'm just going to kind of plug in 0 through 5. You would get 0, obviously, for that first one. But then 3, 6, 9, 12, and 15 when you plug those in. Once you have that, you can decide that this is going to be a discrete domain because you have a whole number of video games. And then for C, whenever you graph the function, that would essentially be, I'm going to kind of rough sketch here. So when you start, you still have your $0. So 0 movies represents $30. If you take away 1, that'd be about 27. And then 2 would be 24. 3 would be 21. 4 would be 18. 5 would be 15, and etc. So they're just going to continue to gradually go down. Oops, and that should not be aligned because it is discrete. Okay, so the more money you spend, obviously your points are going to continue to go down until you don't have any more money. Okay. The last one for number 16, it talks about how far is the train from its destination after 8 hours. What you would do is plug in the 8 with the 110, and that's going to give you 495 miles. So it would be part A. The next part, though, it says, how long does a train travel before reaching its destination? And what you're essentially looking at is the 1,375 is going to be your total mileage. So what I essentially did is I know that 8 would be 495, so I just started going up by 10s. So I tried 10 to see what I got there, and I got 275, so then I tried again with maybe 12, and I got 55. So I know it's going to be a little bit more, so then I tried 12 and a half. And that is where it gets me 0. So your answer for letter B would be 12.5 hours. Okay, just when basically it is equal to 0 is what you're stopping for. Okay, that's going to conclude our quiz review for Chapter 3. Good luck on your quiz tomorrow, and thanks so much for tuning in.